Today I want to talk about multi-threading in MATLAB. So modern computers have always got more than one CPU core, typically at least 4 on most laptops, but can be as much as 32 or 64 on desktops and so on. On my machine, for example, I have 8, which I can demonstrate with the CPU info command in MATLAB. And CPU info is a function that you get on the file exchange, and I'll put a link in the information section for this video. So we see here that I've got 8 CPU cores on this machine. Now it turns out that you don't need to do anything special to make use of all of these cores with a lot of MATLAB functions. So let's create a couple of large matrices, for example. So I'm going to create a 5000 by 5000 matrix called A and a 5000 by 5000 matrix called B. Okay, so they're now 25 million element matrices, and I'm going to multiply them together. So if we do A multiplied by B, so this is matrix multiply, and I wrap that in tick-tock. We run it a couple of times, and we see that that takes 1.34 seconds. Now, that matrix multiplication was done in parallel. MATLAB automatically parallelizes a lot of mathematical functions in linear algebra, sorting, image analysis, and so on. There's hundreds of functions that are automatically multi-threaded. And I can demonstrate that by actually telling MATLAB to not use all of my CPU cores. So now it's using 8 because by default, MATLAB will find 8 CPU cores on my machine and it will use all of them. But I can change this using a function, a built-in function, called max num comp threads. So I'm going to set this to 1, so I'm only going to use 1 core. Now it's returned 8, this max num comp threads function, and that's because what it does is when you change the number of threads to use, it returns the number that it was using previously. So it was using 8 and now it's using 1. So if I press the up arrow and run that matrix multiply again, we now see that it takes much longer. It takes 4.837 seconds. Okay, so it's longer. And if I change maximum comp threads back to 8 and run it again, then it goes nice and fast. Okay. Now, one thing to notice actually is that here I have 8 CPUs, 8 cores, but I don't have an 8 times speed up. The speed up I have is roughly speaking 4.837 divided by 1.321. Roughly speaking, I get a 3.6 times speed up going from 1 core to 8 cores. And the reason for this is that you never get n times speed up for n numbers of cores when you're doing parallelism, unless you're very lucky and you get something called an embarrassingly parallel problem. Matrix multiplication is not an embarrassingly parallel problem. There is always some overheads to do with moving things around in memory and so on and so forth, and you never get an 8 times speed up when going from 1 core to 8 cores with something like matrix multiplication. But still, it's using all of my CPU cores. This works for a lot of functions. Other examples are FFT, EIG, ML divide, so that's the backslash, singular value decomposition, and so on and so forth. And so I just wanted to show this because some people say that MATLAB is a single-threaded program. It's not. It uses multi-threads, multi-cores a lot of the time, and it's just that it does this behind the scenes without you needing to do anything.